Okay, good morning, and I would like first to thank the Van Leer Institute for this invitation. For me, it's an honor to be here, and also thanks to the colleagues talked before. I think the building is very sensitive, is showing some poetry, so I think it's part of the sustainability, you know? And which is rare, you know, because we talk about the green, but I also think the quality of architecture is also very, very important. So I will start this presentation with an introduction about, I'm sure you are aware about this issue about green buildings, but I think it's always very important to see the big pictures, to see why it's so important to work in a small scale, you know? And that's what I call the vision. And I'm starting a little bit far away, but I will be quick in the point. So this is the scale, I mean, it's a geographical map, but if I change some parameter in terms of dimension, and I put this, this is a modification of a map based on the oil power. So a country using fossil fuel to run the country. And that is showing what does it mean north and south of the world in terms of economy and development. So I can see in this map, you see Italy is very fat because Italy is 80% depend on oil. But you can see also other countries like Japan. I just noticed also Israel quite big too. But they're also showing the debate on Durban. You know, it's finished yesterday, the big debate. I was there last week for talking about some green schools and buildings. But I think the interesting of Durban final chart is about transforming these oil power countries in green economy. So shifting the CO2 emission also to the green power and green economy. So I think this is a really, really interesting thing. But if I look also in a different point of view, I can see this what we call ecological footprint. So it's the size of the land we use for running our style of life. And you can see again how one of the major points is not only the consumption of energy, but the style of our life, whose demand more and more production, food, electricity, and many other things. So you can see the map is very different. And then when we talk about Africa, South America, other countries, and the reason why they pushing to be part of this game, I think is we must be careful because I think there's not enough space in the world to make everybody the same level of life. So, and what we know is already that we need already more than one planet. And the way we live is already more than we have. So, and that's, I think, is critical also in terms of, also in the vision about the relation with technology. I mean, I want to show you something about this, but I think we need to really change our mind in the relation of how to make building for the future. I mean, I think we need to be very careful in the way we think in the future. So, and then just to give in the measure, what ecological footprints mean, and biocapacity, then you can find all this information on the internet. But it's really give you the scale of the two real scale of a problem in the country around the world. Impact. So based on what we find as an information, when we talk about zero carbon economy, or when we talk about the green economy, I think we talk about something really serious because I think we don't have an option. There's no an option. And if we run the business as usual, and then we are in 2010, I think we get a really serious problem in the next 50 years. And then why I think the agreement in Durban talk about 2020 and vision of 2050, because as the business run today, I think is no chance. So I think moving to zero carbon economy or green economy, whatever you want to call it, is a fundamental. And then buildings can play a fundamental rules. I must tell why I think architecture is very important, whatever is important in any case, but buildings consuming almost 50% of all energy produced, which is meaning a very, very important issue is design the next generation of building which are reducing dramatically the demand of energy. So why is so important? Well, there's many reasons, but I collect this as a timeline agenda, no? From 1973, what was the petrol, the oil crisis. No? From that point to in the last years, you can see how much progress was done in many events, from Rio de Janeiro summit until the new regulation in many countries in Europe. Now, in Europe, there's a regulation in reduction of CO2 emission in Germany. England fixed a parameter of zero carbon house in 2012. So there's a massive attention by politics about how to reach this agenda on the next 20 years. And also certification in buildings. Now, it's very interesting, and I really appreciate the conversation about the Israeli certification, and we are working more and more with the LEED, the American standards, but also in many countries, like in Italy, every region, they have a different parameter and different regulation about how to reduce the energy consumption of buildings. So showing that in time, the appointment and the goals is coming quite dense, and we see what happened on the next 20 years. I think the Durban fixed some ideas of what will be the action of post-Kyoto on 2020 and 2050. So, and then is implementing best practice and managing climate-related costs, because always we talk about cost, no? And I think sometimes clients, they only see the capital cost, because of course they invest the money on the building construction, and how much the cost, the running cost, about the energy cost in time, how much is in 20 years. So and I think we need to see also the consequence of related cost on climate. So what would be the cost of, the consequence of climate change in many countries? In Italy, I'm talking about Italy, there was, in the last 10 years, a lot of problems on heavy rain and movement of earth. It cost a fortune, billions of euros to repair, and no action to prevent action like this. So the cost of the consequence is much more bigger than preventing cost. So it's I think it's really a shift in the point. What we need to see the difference. The future is different, and I think we need to change our point of view. I will bring in this to see what will be the major environmental fact. So you can see from colors what is extremely relevant and irrelevant. I could say today still energy and water are very relevant, but you can see pollution, transport, waste, and other things. But what happened in the next 20 years? In the next 20 years or 15 years, energy and water will be the two major factors of conflict, but also the two major factors we need to deal how to, improve this relationship. And you can see pollution is reduced because if we switch the attention to the new green economy, maybe and electrical cars and maybe more efficient system of cooling and heating, then we will reduce dramatically the pollution in the next 20 years and noise, but still have quite a little problem about climatic outdoor amenity. And of course, the major point will be access to water. So I think this is also help to put ourselves in the agenda. I think it's always when you design, you need to have some priority in your agenda. If you just moving environmental issue in top of your agenda, I think you start thinking in a different way you're building. And just give an example of the timeline and how the cost in a building. So you say, and the two lines is the cost on structure and facade. I say that because sometimes we need to decide where we're going to put the money on buildings. Structure, it doesn't really change in time. It's always very solid. You're not going to move you're not going to replace the structures. And facade, in time of a building life, you maybe change 2 times. M&E, engineering, mechanical and electrical service, the life of this equipment is quite short, like 20 years, 15 years, depending on the quality of the product. Of course, furniture change much more faster, but IT technology, we change very quickly, all the time. So when I'm looking at this, I say maybe what we really need to invest on the buildings in terms of future is really about the structure of the building and the facade of the building, because they are the two permanent things that we'll be keeping for a long time. Investing on facade has become very important because you're not going to change so often, and facade is always a sort of a climatic moderator between outside and inside of the building. And talk about sustainability. So I'm sorry to be like a little bit an engineer, but I'm not an engineer. But when we talk about solar energy, renewable energy, I think we need to understand and we need to change the process of how to design your building to hosting this technology. You know? And I think the circle starts from the first, which is the blue, about the demand. I think the first point in design green building is to reduce the demand of energy by design a minimization of demand of energy in buildings, using something that we call more passive, you know, the orientation of the building, the thermal mass, the shading, the natural ventilation. So I think we need to minimize the demand to optimize the demand of energy. And then the efficiency. So I think the way you're using machine, you know, like in this case that we saw before, the geothermal energy, you know. So you start to design a building with reduce the demand, then efficiency in terms of machine, and then you can use solar energy or renewable energy, because if you don't do that process, there's not enough sun and there's not enough renewable energy for running around buildings. No? And then also use the alternative. I think this is very important, because sometimes architects, I say myself because I know the work, I know my colleagues. Now, sometimes you want to design a building as usual and then try to put some solar energy technique, and this thing doesn't go together, because I think you need first start your process of reducing the demand. And to do that, I think it's time for architects, and it happens in many occasions, then the teamwork with the engineer is very important from the beginning. So because if you don't really creating a dialogue between architects and engineer in the shape of the building, the orientation, some technique, it's very difficult then in the end to get a really good performance buildings. So responsibility. This is the work I did in the last, say, 10 years. And it's every single dot is a building. That's what we design, and then what we have built in the last 10 years. And from this picture, you can see the gray is the standard, or what we call a standard by regulation, the performance of the building. And the gray is the work we did. So we try to use in some way to, I don't think we are always happy by the regulation. In some different countries, they don't give you any indication about reduction of energy. And in Italy there are, but we can improve. So the difference between the two is what we call building by regulation, and the gray is the performance we improve on the building. No? And you can see there's a constant work on reduced building. In China, we did 2 buildings, which was much easier. The great difference was big, and some of the buildings are like the big one is a shopping mall, which is difficult to reduce so much, but still 30%. The other building, they try to do the best. But I think what happened in these things was very interesting when we did this analysis is about this, you know. So we reduce more or less always by the work, I say this value of 55% of CO2 emission through improving by the machine and the design. But what we were very surprised, and which I think is why is important the architects, why the architects so important in this process, is because you can improve the reduction of CO2 emission by using technology, of course using more performance equipment. But I think the most part of the work is done by the design of the building. So the way the building is designed, the way the facade are made, the orientation of the building, the strategy of a passive or active strategy. So I think that's showing by the knowledge we have, the information we collect in the last 10 years, how much is really the way the building is designed and the work of the architectural design. So I saw that because sometimes I feel there's always the hope that you're using technology to make your green building, and I feel that is quite wrong. You don't use technology to make your green building, but you design better building, and then using technology. So then with this, how much CO2 emission we save in the last years, and then we make some. There's a site on internet, and then you can put the equivalence ton of CO2 emissions, and they give you some. I think the most interesting is one about Italian coffee every morning, safe, and also showing to the client how much money we save in terms of buying oils. So I think in the last years we working in different countries, what are really the two major issues in terms of also of politics. Now, diversity of culture and eco-solution will be essential for people in the future. And I'm saying that because there's a lot of conflict in the moment also in different countries in Europe about the pollution problem, traffic problems, healthy problems, so hydrological problems. So aspects related to the environment, creating really, can I say, attention, no? And it will be a political issue in the future, how the politics and the political issue, are they able to moderate in this conflict, no? So, and I think there are some eco-solutions available also for buildings, and I want to show you something about, somebody talk about the smart city and smart grid, which I think is very interesting. And I show you this example because I feel very comfortable when I'm thinking about eco-solution. And it's about this. Now, this is picture, don't say too much to you. He's a Bedouin with the camels, and he's like a Bedouin. But if I look this in a different perspective, this one, you can see this is a doctor, and the camel have a GPS antenna on the head, so the guy is using a mobile phone, and the PV cells provide electricity for a battery, and the battery supply energy to the fridge, and there's medicine in. And these guys go in the desert to cure the children. So this picture for me is very important because showing what I feel is the relationship between technology and tradition. No? I think we have behind us 2,000 years of history of architecture with no technology. Technology is a really recent invention. It's only 200 years. But before, architects was able to design building in a very good relation with climate. It is full of fantastic solutions around the world. I mean, in Middle East is fantastic. And I have a little story to tell you in the end. So I feel we need to make a shift between a technology shift through a knowledge. So I think the problem is how we be able to have enough knowledge to design building in a proper climate and then use the technology. So in this case, you can see it's the most advanced technology with a very traditional relationship with that climate. It's impossible to go around the desert with a jeep because then you need so much gasoline, then you cannot able to run. But these guys and these camel, they can. So I like this balance, between technology and tradition. So I show you now some building because maybe you thought I'm talking too much. I'm not doing my work. So it's this is a building we did for the Minister of the Environment in agreement with the Minister of Science Technology in China, in Beijing. And this is a building for a university building in Tsinghua University, and is actually the build environment department. So when we start the project, it was interesting because Italy invested 20 million euro on the Kyoto Agreement to show in China, this is a decision to do in China, to show an eco-solution in a country where it grows so fast, then maybe it was interesting in terms of economy and business and also on knowledge transfer. So the building was the idea was this, consider these leaves as our building, as a concept. No? And the idea was to design this building on this simple sketch you can see on the top. maybe is over there, exactly. It's a building based on one direction, is the south and north. So the green dots are the south facing, and the wall is in the north face. And there was a fix on that place. Then we analyzed with the Polytechnic of Milan, the university. We study, make a lot of work on shading, in shape the building. And we have these three strategies now. So first, the building is facing south, is with terrace. So we benefit to maximize the solar radiation in the summer and the winter. And then the building is quite a wall, like a shoulder on the north face, because the north face is wind come from the Gobi Desert in the winter. It's very cold, it's freezing all Beijing for a couple of months. And we want to keep this building protect against this wind. So it's a combination of three basic strategies. So the orientation east and west, the facade is allowed us daylighting during the morning and the afternoon. So we have two wings that always benefit for daylighting. PV cells, the photovoltaics on the roof, on the terrace, then providing shading and energy, and of course the green of the terrace. And then the efficiency was done by, fortunately, the campus, they're using a natural gas for running the heating and cooling system. So we're using a cogeneration. It's a machine that was made heating and electricity, low temperature system on the roof, on the ceiling of the building, and photovoltaics. And the idea was, in the middle season, when temperature and the humidity outside are quite on the zone, comfort zone, to using the building and selling energy. So the buildings produce more than the building need, and selling energy, which I think was also one of the points of your institution. So I think this is one of the parts of the solution. I like thinking that the next generation of building are not anymore the problem of energy, but maybe the solution of the energy problem, because every building can be a little power station that produce for themselves, but when they don't need, they can put on the grid, which I think is absolutely available. No? And so that's what we say in the end, by using a different system of air conditioning and the building shape, we get at least 86% of CO2 emission based on Chinese buildings on 2006, which looks so much, but in reality the level of standard building in China was so poor that it was quite easy to increase faster. No? And I think it was a very interesting discussion in Beijing, because at a certain moment the Chinese academies from academia said, well, in China, our buildings are fully sustainable because consuming 55 kilowatts per square meters, and the Americans consuming 560, the European 350. So they showing that there's no any ecological problem in China, which is quite strange to listen from them. But then he said, well, how you do it? No? They said, well, we allowed air conditioning only 2 hours a day in the summer, and we only allowed heating system in the bedroom 2 hours in the night in the winter. So, well, if you do like this, it will be very difficult to compare consumption, because we are now living in dictator areas, and I hope so we don't need to arrive at that point to reduce energy consumption. And this is the section through the building. It's the 2 levels of parking, a garden. And strategy is about shading the building in the summertime, improve with the garden the ventilation and the cooling through this is a sort of a fountains and greenery. And in the winter, optimizing the solar gain, especially for daylighting and the passive heating. So this show this is the Gobi Desert about behind the buildings, and this is the building. So the 2 floors are public, and the rest of the building is departments. So it's office and teaching class. So this is a map. So you can see the C shape help us to have to optimize the sun and daylighting during the day by east and west facade, but Also, this is the north face, very well insulated. 70% of the facade is opaque. You can see from here, very heavy insulation. And the east and west, we're working with an open double skin facade, so we allowed ventilation through this area between the two glasses. But behind, you can see, is a 50% of the building here opaque and insulated. So that's allowed us to reduce, of course, the demand of heating and cooling, but also increase the ventilation through the two gaps like a buffer zone. And using some detail, which is full on literature and architecture, but light shelf can help quite a lot, improving the daylighting inside of the building. So bring daylighting through the room. Some detail. You can see the double skin and the terrace. And this is the internal garden facade. And this is the building after a couple of years. And this terrace is green, go up and everywhere. And this is the terrace system. So the idea was the terrace was grow with greenery, and the cantilever was another leaves, but it's photovoltaic leaves. And also these cantilevers help in the summertime to shade totally the south facade of the building. So you can see in these pictures the photovoltaics and the plants and the building. So. And this is the internal garden. So it was very important that building was open. It was, you can cross the building. It's not a wall. And the first level on the ground was is a public exhibition center and a conference hall. And the first one was another exhibition. So you can see this is the entrance of the conference, and that's the building from the street. And that was a very interesting experience, also because the Tsinghua University is very knowledgeable on green issues. It was a very good partnership also between university in Italy and then I did this project for social housing. There's a big debate, and I noticed in the newspaper that also here was a big debate by young people about affordable house. And a big discussion. Well, in Italy, there's 5 million people they have very difficult access to housing, whatever rent or buying house, and a young couple have very difficult access also to this to the housing. So we make a proposal. I'm not designing a residential building, but in this case I think it was very important to give an example and study housing by three points. One was about buildings. Housing is related to people. Sometimes the market have an ideas of typologies, and desire of people are totally different. Second one is combining with solar technology, and third one is using a prefabrication system. So maybe putting down the cost, and that building is about building one loft about 100,000 euro, which is quite low in Italy, considering that normally a house costs between 2,050 and 4,000 euro by square meter. So the idea was, this is a 3-floor plus the ground floor, so it's a 4-floor buildings. That's why, because the roof is 100 square meter of solar PV cells and provide enough energy for all the apartments. And also the way you access to house is not like a condominium. Of course, this is a low density buildings, but it's like a more a community. And we are working with sociologists, and I think when you look and you talk with people, talk with family, everybody have a different way of style of how they want to live in apartment. No? And there are different structures in the family. There's the young people, there's the people with the middle class, the people with more culture, the people, the older people, they want to house very protected and close because they're scared. So in reality, the picture of outside is much more wide. It's much more complex than what the markets offer to people. No? So that's why we decided the building will be like a frame and 70% opaque, and you can sell only the loft. You can sell 100 square meter space, and then everybody organize the space whatever they like with the economy they have. If they want an open space, they keep it open. If they want to close, they can do. They go to IKEA, they buy stuff, and they do themselves. IKEA is an incredible thing in Italy. I don't know if you have IKEA here, of course. And in Italy it's booming because Italy is a country of design, but nice furniture are always very expensive. Huh? And then came IKEA, and then put I think nice design, maybe not perfect in terms of material, but very cheap. And then the IKEA phenomenon is interesting because people go inside, take a pen, and start to design their home. No. And it's very interesting because they start to relate it themselves with the picture of the kitchen and the bathroom. I want this one, and everybody working with the idea that is the latest place when you really decide what you want to do. No? That's what I think. Buildings, simple buildings with performance, but leaving the space to people to organize is something that is totally missing in the market. No? And that's what the announcement we did was a home for €100,000, low cost, dream home, and low environmental impact, zero bill, zero CO2. And that was a big news, because at a certain moment people start to call, and I launched this 2 years ago, and we still have people in the call office to say, where do you build? Where can I buy this house? Can I buy this house? Because €100,000 is not really a lot of money. No? Especially if you design a building where, in this system, and also by the Italian regulation, if you produce clean energy, your kilowatts is paid 4 times more than a standard. So if you're able to have a very low energy performance house, you can sell the energy, and you can get a microcredit, which is about €200 a month, which is enough to pay half of the mortgage. So why are we not going to do it? Why are we not going to do it? Why not? So, and then let's start to this system of thinking that housing, maybe construction is a problem. Construction is something then polluted using material, but maybe construction is also something that's solving problems. I want to look at this as a positive action. No? So, and that this is a model of also a different organization of the housing. There's no one lift with the stairs, but a different way you access to your apartment. And there's a lot of demand of community. There's a lot of demand in many countries, in Italy, but also we are working with these people who analyze families all around Europe. There is demand of creative sense of a community in buildings, not a sort of nobody want to know my next door, no? That's, it's partly true, but it's not true. And I think the architectures can help to improve or not improve quality of relationship. And of course, it's combining the two techniques, the geothermal that we heard today, and the electricity by the solar panel. Now we are under construction of public buildings in close to Bologna, which is the Agency for the Protection of the Environment. This will be public buildings, and I'm saying is always a question of tools. Architects, they use in pen, AutoCAD, drawings, models, but also there are some environmental tools. In this case, this picture showing a laboratory in Lausanne, in Switzerland, and is an artificial sky. So it's a place then you go with your model, and you analyze the quality, the quantity of light inside your buildings. And that is a new generation of tools. It's a toy also, because it's quite funny, you go. But also you can use, of course, digital, whatever you want. But I feel always very interesting on the practical activity. So you make your models, you bring that in a laboratory, you make your test. And 1 day test in laboratory costs €500, so it's not in relation of any fee or anything you put on the project. So the models and was 150, and we make all this test on the analysis. And of course we do also using Radius. My office is, we have different expertise. So we're not, of course we work with the engineer, fundamental, and they do the work. But in the beginning, especially in the preliminary stage, you maybe don't have the chance to work with all the engineers and pay the fee to everybody because the client asks you to make a preliminary design. And we have two architects who's working on simulation, so they are coming from PhD studies, and we have a model maker, we do all the models. And that's helped us on the beginning of the process to make the first analysis. So we just like, we want to know where we're going. And then, of course, I mean, we're not going to want to be engineer, but they're working with us. But in the beginning, we do this kind of analysis. And this project is about what I call forms and performs. So how much the form of the building can be help the performance of the buildings. No? So in this case, this is only one floor buildings, which is a laboratory and office, and the roof is this kind of a chimney looking the sun, and we are on a climate, very hot climate in the plain of the pole, so in a very low area with a high level of humidity. So what you need to do, especially in the summer, is increase the natural ventilation to provide more airflow, and also you want to keep in the winter, you want to use the chimney as a collector of hot air. Of course, that's not enough. No, of course, you need a radiant ceiling, then you need a little bit of fresh air. So it's not enough. But what I'm saying is, if the building themselves, by the shape, is already able to do some work, in this case, we talk about 30% of energy saving in the summertime. By what? By using this chimney as a chimney effect, so collecting hot air in the top and run and, increase the ventilation inside of the building through this garden, or in the winter time when the sunny days, collect the hot air on the top of the chimney and with the fan mix the air, warm the air and recover the system. So in some way we try with the shape to optimize. Then of course we need another extra, but this is done only by the shape of the building. So. And this you see the models. And this is the project. So. And it's the first public building done in Italy it's only in wood construction. So it's done by a company from the north. We are not very far away from the forest. And it's a company they do all prefabrication in wood. It's a clean site. It's only a platform in concrete, and then everything will be built on site in prefabrication system. Then, if I have a little bit more time, I will be showing this. Okay, thank you. I hope so you appreciate the work. So this is the 3M company, the American chemical company, which have a very high policy in sustainability. And we did this work for them, the headquarters in Milan, and we was in a very busy street outside of Milan, close to the airport, with this kind of effect, and in a plane there was nothing really around. And the building was done as a very standard office building, because when we are working fully on the market, we are not in a special building, we are working on offices, university buildings. And sometimes I think there's no really point to investigating or rethinking performance on terms of efficiency of an office space. There's a full of history about grill structures, dimension of the space. So we are working using maximize the use of this rectangular space, and then building is north and south, and this is east and west. So the building is exploring the ideas of how to dealing with this. Okay. This is the building. So you can see it's made by very simple vertical model. The facade is 50% opaque. Then the louvers are very important, because the louvers play, of course, an aesthetical part of the project, but also because east and west you need to protect the building, especially in the summertime. You can have a very heavy sun on the facade, and you want to improve the solar gain in the winter through these louvers. So the game is about architectural to think a building, unfinished building, something that is not finished, is broken in like a baguette. When you broken a baguette, everything is broken in the edge. No? And this is what happened on the facade. Why they are so important, you know, the elements of the facade? Because you can see without louvers and with louvers how much you reduce the solar radiation on the facade. The benefit, of course, they are in terms of reducing the cooling demand, but also in terms of comfort. When you make a glass facade, you have a problem when you come very close because you have air conditioning, whatever. But then when you come close with your seat, your table, the radiation, the surface is very hot. No? So you need to you move your table and you not optimize the use of the space. So, and that's the work they done by the louvers, you know, reducing and be very close and maximize the use on the space on the office. No? And we have a 2 little courtyard, so we're using the little courtyard to ventilate the building. Of course, the client invests 2,050 square meters of photovoltaics on the roof, bring the building in CO2 emissions because we're using the PV cells to balance the use of electricity. And this is, this is a classical speculative office building. I mean, it is in the market, costs 1,500 euro per square meter, which is perfectly in the market. And then what I'm saying before is really the question how you think you're building, not about how much money you put in your building. Of course, it is an extra cost because the client put 2,000 square meters of photovoltaic and spend quite a lot of money. But the building can be run in any case. So it's the way you using knowledge to use the money. And this is the detail of the building. And that was another really very interesting experience in China. I'm visiting professor in Nottingham, and I was asked to make this little center for sustainable energy technology, which is actually a PhD student buildings on that matter. And the Nottingham University make an agreement with the Chinese government to make the new campus, and they make a campus for 22,000 students, and they built in 18 months. So this is a Chinese way to do it. No? Huge campus, and also they did because one of the major profit of the campus in England is come from Asia. No? And then they started to reduce the entries because too expensive. So they built a campus in English. It would be an English campus, and then some of the students they can go to do the master, only the master in England, but they do the diploma in China. So it's huge, and then the building they asked him to make it was a small building, you know, like about I think it's less than 2,000 square meters. You know? So now I thought about these ideas of a little Chinese lantern in the middle of this huge campus, no? And that is the building. So it's a little things in the middle of this park, and come from some ideas very simple. Fans, they're very efficient in terms of cooling because fan it creates evaporation in your skin, and evaporation creating the effect of freshness. And this is one of the elements of the facade. No? And they plant 10,000 trees on the campus, and then when we start the site, they take a year. These pictures taken after 3 years, and after 3 years, because we are in I don't say tropical area, but we are very south of Shanghai. It's very humid and very raining a lot. So you see, all the greenery is booming. No? And so the building is mainly made by 2 elements. One inside, you can see from the picture, is very heavy concrete, very well insulated, 30 centimeter insulation, boom. And then make the building very safe and protect by very hot summer and humid, and very cold and humid winter. So it's the worst scenario you can make a building. No? And then the other part of the building is this sort of a double skin, which will help to ventilate the building. But mainly is only working on this facade, which is the only facade of the building. And then I show you the strategies. And it was a funny story because this is a donation by a Chinese Hong Kong developer, which is 38 years old, which make a fortune on make buildings in Hong Kong and China. And he decided to give this as a present to his wife because I think he have enough diamonds. So he said, well, what I'm going to do is I will make you a center of research. And then I thought it was a female buildings, because it was dedicated to his wife. And then we make this presentation, and the idea of the building was like a dancer, It is movement. There's no one side same as the others. And would express in some way the ideas of gentleness, and that was the opening. So it's a part of laboratory in this part, which is semi-underground, and the class up in the floor. And this is a part of the double skin is open, and you can see the big walls behind, which is the very well insulating walls. And when they asked me to do how many photovoltaic panels you want to put on the facade, I say none, because I don't think we want to show in the architecture. Green architecture is only made by photovoltaics and windmills. That doesn't make any sense. Because first they're terrible looking, because you see buildings, you can see many buildings with all these photovoltaics in facade. I find that really, really terrible. And I think what we want to express is not only the technology, which is okay, but the combination of different techniques, because the future of building, they are not related to one technique, as before. Air conditioning system, you can do cooling air, you move all the air, you do everything. But it's combining different techniques. So the way you design your building, the thermal mass, the ground cooling, the PDAC, the evaporation system, the natural. It's a little bit more complex, but that's the only way to do it. So the sketch we did and was overlapping with this performance. The idea is combining, the ground floor, which is a very large area touching the ground, with the ground cooling, so moving the air through the foundation. Using a little system of a chimney around the stairs to improve the ventilation to the top of the building, and using the thermal mass of the floor for heating and cooling the building. Maybe I'll show you this is much easier. So as a center for sustainable technology, I think was a showcase. I think we need to show there are a system of geothermal, there's a cooling system to cooling and heating the building by the ground, is a thermal mass with the water coming through the concrete mass, is a ventilation, and then showing that you want to do a sustainable building, I think you need to think seriously about combining all these techniques. And this was incredibly successful, because in the end, there's no one solar panel show. And of course, pass through, this is done by our engineer in Nottingham. Of course, it is a lot of scientific work. Sometimes I feel when we talk about architectural only as an aesthetical problems, I think we lose the fundamental of architecture. Architecture, of course, is an aesthetical action, and is must be more beautiful we can. But behind architecture is a scientific work. It's not. Sometimes they go, Are you an artist? I'm be very happy to be an artist, but unfortunately I can't, because my work is fundamentally a scientific work, because I need to dealing with contractors, technology, cost, regulation, and be also an artist to do a nice building, But this is a part of a very complex process, And so this is the winter strategies. Using the thermal mass of the building, of course, using all the possible technique to show you how to dealing with this, and of course combining the technology. This is absorb chiller, and that's the buildings in the end, and that's the only things they make against my point of view is this little windmill, because they say we can. No, we are did, but this we are making the wrong picture. No, these are the only things. They was I resist, but I was impossible for me to but fine, you know, the photovoltaics was done in another area, like a vegetable garden. In front there was all the panels and everything. It's much easier to clean and maintain. No? And that's the little lantern. Then I'm doing a very interesting project in Africa for an English developer, and it's about make an office building in Accra, which is in a tropical area. And of course, the first question of this building is how to design buildings in this kind of climatic area, because in Ghana is a very nice country, but all the West Africa is still in underdevelopment. You know, first Nigeria with Lagos is the booming area, but Ghana is also very. The GDP of Ghana is about 13.5% of growth, so it's countries that go very fast. And how are we dealing with new buildings in this area, using different reference? The first idea was because the sun is go vertical very quickly from the morning, because we are on the almost in tropical area, and then the morning is the angle is go up very quickly and they stay up and then go down very quickly. You know? So the most important thing is shade the building. You know? So the buildings is done by these cantilever floors. Maybe I can show you some. Yes. Cantilever floors. So when you have these cantilever floors, then you can have a totally shading facade, and the facade is 2 or 3 meters behind and can be totally transparent because there's no any solar gain. And it's a fantastic. It's the first time we are working with no thermal bridge, which is very good. You know, this is one of the problems we always design, and no heating problems. So this the only problem is cooling and managing the daylighting, which is sometimes too much. So this is the building. It's come like a palm, you know, the palm I showed before, the palm tree, you know, with this hexagonal system. So we thought of something organic like this, and is imperfect, because I find sometimes with this research of perfection in building is quite strange. You know, I mean, like temperature, no? We talk about the green building, and then we want 22 degrees and, I don't know, 65% of humidity fixed all the time. When we come out of this door outside, there's another world. You know? But we want this perfection only inside of our buildings, and then cost a lot of money in terms of energy. So maybe we need to change the parameter of what temperatures mean, comfort, what does it mean, and maybe we talk about the adaptation, so we can also adapt ourselves for different condition inside of the building. So that's by our engineering work. We make this analysis of temperature, humidity in area, and we see there's a 40% in terms of occupancy of the building. We see there's an area between 20 and 28 degrees. Then we can improve using natural ventilation, because we are close to the comfort zone, and why not using, no? So the building part for this analysis of the floors, how the floors shading the facade, and how we can improve using this big patio, the ventilation through the windows, through the office, inside of the patio and outside. So this is under construction, so will be a good example. And only doing, that's what I'm saying in the beginning, only by a good choice of architectural choice. So you make the first choice is cantilever because we want to shade. Then you do whatever you want. But already with this, we reduce the demand of cooling peak load, so, which is very important. The consequence is come to, I already make a good effort to make the building, which is reduce the demand, and then now have other strategies. No? This is about the lighting. We still have a problem of glare. And this is the patio with all this connection through the building. And this is the appeal. And I think this is the last two projects, which is, I'm very attached to the last one, which I hope you appreciate. This is a project we are now in the final drawings. Is about Aosta, is the northwest. We are under the Monte Bianco, the Mont Blanc, And is you can see from this picture is the Roman city. You know? Yeah. You see, this is the structures of Roman city, and this is the wall, Roman wall. So that is the historical center. And then outside the wall, they start to build terrible buildings. So it's Austria is amazing. There's many Italian countries, cities, the beautiful city center, and outside they make a disaster. No? And this was a military camp. No? There was a wall all around. It was closed and was very well known because the Alpini, which is the military, go to the Alps. Almost all the Italians went in this area, no, in this building. So, and then, you know, is a change in policy, and then they selling all these public buildings to the local governments, and the local governments decide to make a new campus for university. It's about 2,000 student buildings, and we keep. This is the existing buildings. This is the office, we say, yeah, there are two existing buildings, and we demolished the two wings to rebuild these two buildings for academic class and everything. So, but the idea is always, I always question myself, where the project starts, where's the moment of your thinking, you know? And of course, we was in a glacier, it was very cold, and I think shapers are quite interesting the way, you know, architecture is made by nature, no? So, and then we start with this thinking, no? And that is the model. So we keep the existing two buildings, and these are two very like a melting piece of glass, no, ice, you know, with ideas. Sorry. And there's a big parking underground here for the city, and then is a public parking, the new square, and the two academics buildings, which are more simple than you think. But also we would like to also do some very, very difference between the system of 900th century, you know. Almost the architecture is done by the repetition, no? You know, tick, 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 all the windows, This is it's not only a military architecture, it's almost the architecture on the beginning of the century was made by these ideas of repetition and decoration. So we thought to change this and make this is the repetition, and the shape is done by solar analysis, and the building is shaped through these ideas of daylighting. No? So we try to do a different process by not using tools for energy for verification, which is important, but try to see if we can use tools for energy as a tool for driving the design. So maybe it's not we starting thinking about this is combining like Ecotech with Rhino, putting together, and then Rhino can be able to shape the building in relation to the performance. So I think this is really interesting because we are starting with a new point of view about the formal problems. No? So that's the map, and this of course is a lot of this facade is opaque because we are in a very cold area. But strange enough, in the summertime, because we are on the plain, this area go 28, 30 degrees. So it's an extreme condition between winter and the summertime. No? But the work we did is because we are starting with this project. We think about the classroom, go out like this in cantilever, and then we make the analysis, and was unable to reach the level of certification they asked by the client. No? So, and then say, well, of course, there's a lot of perimeter of glass, there's a lot of area exposed. So we start to move to more compact buildings. It was a very good exercise, you know, to pass from here. Was an exercise in the beginning, and try to optimize, because we see, of course, by optimizing the shape, you increase the performance. You know? And from this and a parallelepiped, a cube, there's not really a lot of difference in terms of performance. So we move very quickly, and quickly with tools, we discover how much you improve the quality of the performance of the building. Also in terms of the envelope, reducing the envelope. and increase the insulation. And also louvers, like in the 3M buildings, louvers can help quite a lot on terms of improving the daylighting in east and west, but also shading the building, provide at least 50% of insulation facade. So sketches. And of course combining two techniques, one using, I don't know what I call it in English, but instead of geothermal, we're using the water, a water tap, you say, water tap? Because Aosta have a big industry of steel, which is closing down, and they're using a lot of water from the underground. And then the moment they stop, the water is coming up quite quickly, you know, because they were not anymore used. So we're using cold water from the ground for cooling and heating the building, and cover all the building in photovoltaics. So and make the building zero to emission. So that's what I'm saying before. Now study the shape through the Ecotech system and try to optimize the curve and maximize the use of daylighting. And these are models of facade, internals, and then the building seems nice. So now I come to the last, and I was involved in the last year I've been in Jerusalem many times actually, with the Italian cooperation, and we did a project for green schools, and there was a joint venture with UNRWA, you know, the agency for the Palestinian refugees, and the ideas was working with them, and we elaborating a prototype of school. Is actually recently presenting in Durban, but also we received the money from the Islamic Bank. So is the ideas of design a building in a very extreme condition. So this is a building for Gaza, and it's a school. I mean, I've been visiting, and well, everybody of you know the story and the situation, and I think. For me, the challenger was if we are able to design a building in so extreme condition, in terms of resource and climate, I think is a symbol of, if we're able to do it, I think we're able to do it everywhere. And I think this is the message of this project. Well, of course, there are many aspects of this project, which is about collecting rainwater. It's still raining, it's still 400 millimeters of water in Gaza Strip. And maximize the using of solar shading and improve the thermal mass of the building. This is a very low-tech building because there's no money, as you know. But that's the effort we did, no? Using these big columns in concrete, using for pipe system, no? They're empty, then we build very quickly, put the earth of the excavation in, and creating a very massive thermal mass inside of the building. The roof is like a scoop for collecting waters, and through this cylinder full of earth, we can plant trees, and trees shade the building. So, but mainly the ideas was maximize the thermal mass, collecting rainwater, shade the building, using the high for ventilate the building and stratification of the hot air in the top. And this is the technique of system of construction. Building quite quick, and this is the column system, and this is the space. So using also the system of cleaning water by plants, we actually finished a little kindergarten with this system, and is 70% of all water is recycling, so we are not going to buy water for drinking. But we recycling all the water, which is mean 2,020 meter cuba here. We'll be keeping on the building, cleaning by the plants, by the sands and the roots, and re-put on the system, and collecting more or less 700 cubic meter of rainwater. So with this, we are able to run almost the school with nothing, with no supply from the external pipes. But also, I think see, this is the plan with this. I thought using this big column help us to, using this column has a thermal mass capacity. During the night they be cooled by ventilation and release this temperature during the day. but we have also to keep some temperature in the winter to release during the day. So I was thinking we are now using almost nothing. We're using thermal mass, ventilation, using the ground floor under the foundation as what we call in English ground cooling. So using we call hair lake. So under the building is a rocky bed. Then we run hair through this rocky bed and push this inside of the class. Of course, it's not. We need to we need to think seriously about it. But this idea is this. And this is the building, and I show you some of the strategies. Yeah. So mainly the building is working with this system of tanks for collecting waters. The wetland is help us to filter the water through the roots of the plants and re-put this clean water on the cycle, and using this rocky bed for pushing slowly the air through the class, and using solar chimney would be very hot and the soak air like a chimney and increase the ventilation inside of the building. So there was a lot of resistance, of course, to do these things. But now we are finalized. They give us a site, and we know why we are now planning the construction problems, because there's a lot of problem of materials and other stuff. And we start now the simulation with Nottingham about, optimize the section and see the ventilation and other problem relating to the air through the back rock bed. So the ideas, this is a little bit graphic, but to say the columns big, they using really to acting like a thermal mass inside the building and ventilating through these columns. And yeah. And of course, everything, I think somebody talked this morning about it, but I think we need to trust also our children and teaching to them from the beginning. And I think buildings are, in some way, an educational process, because if you live in it, it's like everybody of us is an educator. No, we all educating people and children. But building can play a fundamental role, because if you live in a proper buildings and these buildings work and you can show the performance, and also you can show you can live in a better environment, that can be really a serious process of education. And I think we need to really trust and make more this green building to show that the road is possible, and it's only question of knowledge and the ideas to do it. We need to do it, these things. And I think we have everything in our hands. We know the technology, we know how to do it. What is the problem? And sometimes I feel politics, they don't really get the feeling how to do dealing with these things, because the arguments is not so clear. So anyway, I just finished my things. This is the logo of our school, which is, of course, the section of the school, the roof with the trees and the columns, but also our two kids hug each other. Okay, thank you very much.
טוב, לפני שאתם קמים, אני רק רוצה להודות. קודם כל, Mr. Cucinella, thank you very much. For a fascinating presentation. Thank you, and I hope we have many opportunities to hear you again. אני רוצה להודות לאנשי מכון ון ליר, לפרופסור מוסקין, קודם כל ללימור סגי, אני יודע שלא הזכירו אותה פה, אבל בלעדיה אני חושב שכל היום הזה לא היה קורה. כמובן לאנשי מכון התקנים בראשות דני גולדשטיין, לאביגיל דולב שריכזה את העבודה על היום הזה, לדני רהט, לברכה חיוטין, תודה רבה. ואני מקווה שניפגש בעוד הרבה מאוד הזדמנויות שבהם אנחנו נדבר על מבנים בעשייה. ואני מעודד אתכם ללמוד עוד בעצמכם או בדרכים אחרות ולעשות. ערב טוב.